In paper chromatography, as the word implied, chromatography is derived from two Greek words. One, chroma, means color. The second part, graphy, is derived from the Greek word graphia, means to write. Materials needed for chromatography experiments. Number one, you need chromatographic jar. Number two, you need chromatographic paper. Number three, you need solvents, which is to be used as the mobile phase. You need meter rule to measure distances moved by solvent or the compound. Then pencil. Number three, the samples for separation. In paper chromatography experiments, after the process is done, you need to calculate the ROF value of each of them. ROF means retention factor. ROF means retention factor is equals to distance moved by compound over distance moved by solvents. ROF value is always equals to or less than 1. In paper chromatography experiment, after the experiments has been carried out, the colors, the compounds separated. Usually the compounds are separated visually as different colors. So the next thing, the chromatography paper is dried. When it is dried, you mark the various distance moved by the compounds. Now, having marked that, the next thing you do is you take your rule and measure the distance moved by the compound. For instance, where you have different compounds, let's say compound 1, compound 2, compound 3, or compound 4 as the case may be, where the compounds in that mixture is more than 1. You mark the color boundaries. Thereafter, the next thing you do, you measure the distance moved by each compound. For instance, if compound 1, distance moved by compound 1 is measured to be 2 cm, then distance moved by compound 2 is measured to be 3 cm, and compound 3 is measured to be equals to 4.5. In such case, after taking note of that, you need to calculate the ROF value of each of the compounds as being separated as different colors. Now take note, ROF value is always equals to or less than 1. It means its highest of ROF value is 1 or is less than 1, which is must be 0 point something. Now, I've done that now. Now you want to calculate the ROF value of each of the compound. The next thing you do, let's say compound 1 want to having distance moved to be 2 cm. What we do next is to calculate the ROF value. Now ROF value of compound 1 distance moved by the compound is 2 cm. Now remember, RF value is calculated to be equals to distance moved by compound all over distance moved by solvent, which is the solvent front. Now, in an experiment where assuming the solvent front is equals to 6 cm, now compound 1 is moved 2 cm, compound 3, distance moved by compound 2 happens to be 3 cm, and distance moved by compound 3 happens to be 4.5 cm. Now, the RF value for compound 1 will now be distance moved by compound 1 over distance moved by solvent, which is the solvent front, which happens to be equals to 6 cm. Now, when you use your calculator, you are going to get 0.33. Now, the RF value is non-dimensional. 4.5 over 6, which when you use your calculator will be 0.75. This is how RF value is being calculated. Now take note that RF value is dimensionless because the 2 units will cancel out, because all the units dimension of measurements are in the same unit, either in cm or in millimeter. We can go into the practical demonstration. This is a leaf for the extraction of the plant pigments. Now we will need mortar and pestle. We can cut the leaves into smaller pieces. We might need sands, like 2-3 spatulas, to ease the pounding for easy extraction. Now we can pound now. Just for easy extraction. Thereafter we add 10 ml of solvent for extraction. In this case we are using acetone. 10 ml of acetone is to be used. It's poured into the pounded leaf, and then the pigment, green pigment, is extracted. Now we can get the chromatography paper. This is the chromatography paper. We measure 2 cm from one of the ends. We can see 2 cm from one of the ends, and then from that is 2 cm from this end. That mark is 2 cm. Now we'll measure for the other end and divide into 3. That is to third mark. The second mark there is to third mark. We can draw a line across the 2 cm and also the 2/3 mark, and then the point of staining A and B. Let plant extract be A and black ink be B. This is black ink. This is capillary tube that will help us for the spotting. Now we are ready for spotting now. This is the plant extract. For the plant extract, you might stain 1 to 3 times, but for the black ink, just once is enough. Now, spotting of the black ink now. Just once, a dot. Finer the dot, the better it is. That's okay. We allow the paper to dry on the spotted points to dry before separation. Now the paper is ready. This is a prepared paper chromatography. Now we take 10 ml of the solvent mixture for separation. And this time it is propanol, diethyl ether, and water mixture, 1:1:1 ratio. Now we can cover the lid so that the jar, the solvent in the jar can saturate inside. Thereafter, we insert the paper. Make sure the spotted points are above the level of the solvents, and the paper should be placed vertically. You can see in this case is relatively vertical. Now once the paper is placed, the vessel should not be disturbed. Immediately the solvent level rises by capillary action to the spotted points, and above that point you begin to see separation. The solvents will carry the components along according to their affinity. The one with the highest, the component with the highest solubility will be most carried along. You can see the separation beginning now because the solvent level is above the spotted points now.
You can see the color separation. Now, as the solvent level rises by capillary action, you have to be patient until the solvent level rises to the 2/3 mark at the top. This is the 2/3 mark. Until it gets to the 2/3 mark, you don't remove the paper. But immediately the solvent level rises to the 2/3 mark, you can remove the paper immediately. Look at the level of the solvent now. You see the dampness or the wetness. You see the level now. But you wait until it gets to that upper line, this line. Now it's up to now, and we can remove it now. We are removing the chromatography paper. You can see very clearly the separations. Both of them, the separation is completed. So the paper is ready for drying. The paper is ready for drying. It can be placed on a clean horizontal surface to allow the solvent to evaporate before examining the paper. Now the paper is dried. We can examine the paper and look at the separations and mark the color boundaries in both the plant pigments and the black ink. Now I can now mark the color boundary. Look at the color boundary. Each of the colors represent compounds. So I'll prefer calling them compounds instead of going by the color. This is, yes, one color. Three colors for the black ink, while two colors for the plant extract or the plant pigments. Now each of the colors as seen represents compounds. So different compounds are separated. Now that's compound 1, compound 2, compound 3 for the black ink. For the plant extract, let's call the lowest one compound 1, then second one compound 2. That is, now we need distance moved by compound 1, compound 2. Now this is distance moved by compound 1. It's carried from the A point to that point. That's distance moved by compound 1. Now here for black ink, distance moved by compound 1 from this spot to this point. Yes, that is compound 1 or component 1. Then from the origin to that point, that is component 2 or compound 2. Then this is distance moved by compound 3. Now with the help of meter rule, we can know the dimensions. This distance. Here we come to the end of this video. Do well to like this video and subscribe to this channel for more updates.